Related to solving equations and inequalities is the idea of solving a formula that has many variables for one of the variables in that formula. As an example, when you go to rent a truck from a do-it-yourself moving company, your total cost is the initial cost of the rental plus the cost per mile multiplied by the number of miles that you rent the truck. Sometimes when you want to make use of a formula like this, you don't want so many words, so we can simply translate that down to T, being the total cost, is the base rental price, B, plus the cost per mile, C, times the number of miles you're going to drive the truck, M. Suppose we're in a situation where you know you have $200 to spend, you know the initial rental cost is going to be $35, and you're going to have to pay half a dollar per mile. Because we will not always want this equation to be solved for T giving us the total cost, but we might want to, in this case, turn it around and ask how many miles can we drive, we want to be able to solve these equations for one of the variables in the formula. We're going to go through and solve both the formula T equals B plus C times M and the equation 200 equals 35 plus 1/2 M at the same time. One of the things to stress in solving literal equations or formulas for one of the variables in the equation is that the process is identical to what you would have done had all the variables you're not solving for simply been numbers. In either situation, you want to simplify both sides of the equation, which is done. You then want to isolate the variable term. When we refer to the variable term in an equation that has only one variable, it's clear what the variable term is referencing. When we refer to the variable term in a formula that has many variables, we're going to be referring to the term that has the variable for which we are trying to solve. Since we're trying to solve this formula for M, the variable term would be the term Cm. In either situation, we would start by isolating that variable term. In the original equation, 200 equals 35 plus 1/2 M, we'd want to isolate the 1/2 M, and we would do so by subtracting 35, the other term, from that side. And we would subtract 35 from both sides of the equation. In terms of our formula, T equals B plus Cm, we're trying to isolate the Cm, so we need to remove the B. Since it is a positive B, we will subtract B from both sides of that formula. As we will do with the equation and simplify both sides of the equation, we'll do the same thing and simplify both sides of the formula. Let's begin with the equation. 200 minus 35 is 165, and 165 equals 1/2 M. In terms of the formula, when we try to simplify both sides of the formula, it doesn't simplify as neatly as it just did for the equation. T minus B on the left side will stay T minus B. On the right side, B plus Cm minus B will become Cm. So in both situations, we're left with the variable term on the right side of the equation, Cm in the case of the formula, and 1/2 M in the case of the equation. Going back to the equation, 165 equals 1/2 M, we'll finish solving this equation by doing one of two things. Since we're multiplying by 1/2, we could look at this as we will divide both sides of the equation by 1/2, or using what we know about fractions, dividing by 1/2 really means we'll multiply both sides of the equation by 2. In terms of the formula, T minus B equals Cm, we're trying to solve for M, and we're multiplying that M by a C, so what I will need to do in this situation is divide both sides of the formula by C. Again, in either situation, we will need to simplify what we have. In terms of the equation, 2 times 165 is 330, and 1/2 M times 2 is M. And so we have solved that equation for M. In terms of the formula, T minus B over C does not reduce, while Cm divided by C does reduce down to M. And again, we have solved the formula now for M. The key thing to recognize is, where we would have done addition or subtraction with the numbers in an equation, we will do the same thing with addition or subtraction in the formulas. Where we would have multiplied or divided, we will do the same thing with the formulas. The most substantial difference between solving an equation and one of these formulas is simply the fact that with numbers and equations, a lot of the numbers will simplify. 200 minus 35 was 165. 165 times 2 is 330. With formulas, because they're not like terms, because they're not similar variables, you're not going to have as much reduction. So the solutions for the formulas will not necessarily look any better than the original formula did. It'll simply be solved for a different variable. One other difference is when we're solving equations, we always finish off with a conclusion. The solution set is the set 330. When we're solving a formula for one variable, we don't have the same sort of solution. It is true I could substitute t minus b over c back in for the m in the original equation and I would get a true statement, t equals t. But it's not the same sort of solution. We don't have a single number that answers a specific question. As such, we will not need to actually finish off with any sort of conclusion.